Yeah. Hello, welcome to a group project named as Bayesian Analysis of Clinical Trial Data using PYMC3. And this is group 3. Team members Ashish, Srikanth, me, Rahul, Harika, and Vamshi Krishna. Next slide. Yeah. When it comes to the abstract, like estimation of Bayesian methods for parameters like discriminability, bias, true positive rate, and false positive rate across three cases offer insights into medication efficacy and statistical evaluation techniques.
Bias in binary classification refers to favoring one of a class over the other regardless of actual membership. Discriminatory measures a model ability to distinguish between classes by comparing their mean relative to standard deviation. True positive denotes correct positive predictions, while false positive indicates incorrect positive predictions. The binomial distribution model the probability of observed data based on true positive and false positive in fixed trials. Fitting this scenario well, Tino tensor operates in Python MC3 enable the calculations, the cumulative distribution functions of a normal distribution. The normal distribution characterized by mean and variance is commonly used to model a real world phenomena due to its bell-shaped curve.
So when coming to the code part, we are using the Bayesian interface to estimate all the true positives and false positive rates for these models. And here in the code, our dictionary contains recorded data and target data and noise observations and all the samples like false positive, false negative, true positive, true negative, and all the samples. And we are using the PyMC3 model for this probabilistic programming library to define and perform the Bayesian interface of these models. And here we used the pi function to calculate the cumulative distribution function and error function in the PyMC3 library to measure the probability of failing in the specific range.
Hello everyone, it's me Aziz, and so for our analysis part we have three different groups, and for three different groups we have three different scenarios. So in first scenario we have 70 true positive and 50 false positive for 100 targets and 100 noise trials, and for second we have 7 true positive, 5 false positive for 10 trials and 10 targets, and for the last we have 10 true positive and 0 false positive for 10 targets and moist trials. And we can see the discriminability, bias, true positive and false positive mean as well as standard deviation side by side. And for the first case we can see we have 0.63 discriminability, that is very good, it can discriminate between the classes nicely. And for bias you can see it's on negative side, so in case you can see discriminability is 0.1 and that's not very good. Bias is again 0.41, so it's negative side. Discriminability is 0.97, that's very good, this model is doing pretty good. And bias is also around 0, so there's no bias. And in the results we can see it's the same, you can see the same results here. On the left hand side is discriminatory bias, on the right hand side we have TP and FP distribution. And for the first case you can see discriminality is around 0.5, so it's pretty good, moderate model. Bias is on the negative side, not good. And for the second we have discriminality as 0, uh discriminality as around 0, it's good, and bias is around negative. And the final you can see discriminality at 1, that's very good. Bias is again 0, that's pretty good.
In case 1, participants displayed moderate discriminability, that is 0.63, and a slight bias towards negative values. Here, for the relative high true positive rate is 0.67 and false positive rate is 0.52, indicating some ability to distinguish targets. So discriminability in case 2 is also similar to the case 1. There's not much difference, so there's no improvement in the performance. While in case 3, if you see true positive rate is 0.61 and false positive rate is 0.38, where it is decreased because here it identified the false positive correctly. So the third model is excellent in accuracy and in target discrimination with minimum false positives. Next one. So from this, we can see the true positive rate, false positive rate, discriminability, and bias. So in here, in case 2, when compared to case 1, have a similar output or similar result because of its smaller sample size, that is 10 trials, leading to increased uncertainty in parameter estimates. Conversely, case 3 demonstrates high accuracy with less false positives. So using PYMC3 for doing statistical operations on Bayesian analysis will give a better outcome. And that's it. Thank you.